here we are. Let's get on it. Okay, let me open up my Chrome. So, can't update. So usually what I do is I show this dumb, I don't know, well, I shouldn't say dumb, it's not that dumb. It's fine. But I show this timer, right? So I go open timer here, and then I just use that. I mean, if we want it to look like there's hardly anything here, right? Just this timer, this thing moves around or whatever. So, I mean, it's not much. Let's take a look at current events, and I'll put on the time, or the music, excuse me, the music. Music. Oh, and I queued a song earlier. I'm gonna queue another one, hold on. Let me open up my chat. Cool. Okay, let me make a song request. What song do we want to request? How about, let's see what it says. Oh yeah, works for me. All right. Let's see our current events real quick. Oh God, don't show me that. Fewer, please. I don't think I want to click on any of these. Learn new actions faster. I mean, it sounds good, I guess. For you, picks. Oh yeah, I've been seeing this on my phone all day, but I don't really want to click that one either. Let's just go to exorcism. So I should be able to finish up the WASM exercise tonight, right? Like, I'm mostly done with it. And so after the WASM, apparently it's a JQ exercise. I'm not sure what to expect from that one. So I'm just going to try to finish up the WASM and jump right into the JQ. Let me grab my phone first. Bring it over here. All right. Not sure what to expect from the JQ exercise, but hopefully I'll at least be able to get started on it tonight. I think I should be able to. Just taking a quick look at my phone first. This is what I usually do while the timer is going off, is I open the stream on my phone so I can see it. All right, there it is. Okay. All right, let's go to the code that I was working on earlier and hopefully finish it up. Okay, so we're gonna go to here and run test again. So we can see that the tests are passing for encode. These are tests that I added, and these are tests that I added. This is a test that I added. So anyway, so the decode is not yet implemented. Let's go ahead and do it. So the other good thing is, let's grab our decode function. It's going to be kind of big. This is kind of a big file. But yeah, so here's the decode function. So I'm going to move it down. Let's go down. It's not a huge file, but bigger than I usually like, especially for this exorcism stuff. Okay, so I'm going to put decode here at the bottom. And then I'm referencing this Python code because it just makes it a lot easier, of course. It's just Python code I wrote yesterday. So we're going to do decode. All right. So first of all, oh, I don't even have a name on it. I guess it doesn't need one because we're not going to call it. Okay, so we're going to have two params, the offset and the length. So those tell us where to look for our string. The result will likewise be an offset and a length because we're returning effectively a string. But since there's no string support per se in WASM, we really just return two numbers, which are, you know, where it is and how long is it. So that's pretty much it. So it looks like we're going to want a length, so let's start with that. So that will be defined local $length is the name. The type is i32. The type, I think i32 is like the only type that I use. But that's fine. That's fine. It's flexible. It's just a number, right? It's just bits. Okay, so we'll have a length. We'll also have a $I. And again, of course, i32. It's just bits, baby. And then for our return values, we're going to have a output offset, right? Again, i32, of course. And we'll have an output length. Go, i32, of course. So then when we actually return, we won't return these. We'll return the output offset, but we have to do local get, I believe, right? Local get output offset will be 1, and then the other will be local get output length, right? So that'll work just fine. Makes it easy-ish, kinda. So that covers our length result and our I. There's also going to be a C, so let's list that in here. Local $C i32. So that'll be the character that we're working on at the moment. All right. So let's hop into it. So let's initialize some of these. So we'll go local set, and we'll initialize length to i32 const 0, right? There we are. We'll set the I also to 0 to initialize it. Okay. Then we'll do C. That also initialized to 0. I mean, I guess so. We're not going to actually use it as a 0, so technically we don't need that. Let's just delete it if we don't need it. Before we even initialize these, we should probably initialize our result string. So that's going to be so this one is going to be put after the input. So I believe this is what I did before. I did i32 add, and we'll add two numbers together, of course. And the first one will be local get input offset, and we'll add to that input length, like that. So we add those together, so we'll put the output after. Let me go up so just to look and see if that's the same thing I did here. Yeah, that's the same thing I did here. Okay, let's go down again. And so let's initialize the length. And that's going to start off at 0. Okay, so we'll do that. Cool. So that initializes everything, I guess. So then we'll have a loop that happens. So I'll call it loop. I'll name the loop decoding. Okay. Let's put it in a parenthesis again, like we did before. So we'll return after the loop has ended. And maybe after some other things. So another thing we want to look at is if the length of the input string is 0, then I'm pretty sure we want to just output 0. Now, the Python code doesn't check for that specifically, but in the WASM code, I get to check for that specifically, I think. So we're going to say if, and then we'll put a condition. and we'll put a then, and we'll put an else. And then I believe this loop is going to be inside of the else. Okay. This then, I'm going to make a no-op. And so then this is going to say if I32EQZ, is EQZ here? Have I used it? Yeah. That is what it is, right? It was, let's see, it's not a control flow. It is a numeric comparison. EQZ. So did I not end up using EQZ before? I thought I had, but whatever. All right, so we're going to check if it's equal to 0. So what did I do before? I put the 0 here. So was I thinking that I wanted to use EQZ? I'm going to leave that alone for now, but maybe I'll refactor at the end for that one. For this one, I just want to use EQZ. So then we just put local get input length. Okay, so if the input length is 0, then we no-op, and we just return at the end, right? Because we've already initialized those to an empty string. All right, so then all this goes in the else, our decoding loop. Let's do it basically like that. Okay, so inside the decoding loop, let me reference the Python because I need the help. Okay, so first of all, it says we're setting the char. So we're going to say local set $C. So what are we setting it to? This is going to be I32 load 8_u. So we're loading 8 unsigned bits from where? So we're loading those from input offset. No, we're going to have to add, right? So I32 add. Okay, so the first addend is going to be local get input offset. Okay, and the second, whoops, will be local get I, right? So that's string sub I. Okay, so we'll add those together and load the char. Okay, so that covers C equals string sub I, basically. Okay. All right, so then we check to see if it is a number or not, or a numeric digit. So we'll put an if here. So we'll have a condition, a then, and an else. So the condition is like we said here. So do we have an and? I guess we probably do. I don't recall having seen it yet. Let's see if it's under control flow. We have bitwise and, right? Should we use a bitwise and? Yeah, a bitwise and is fine. Let's take a look. So it's I32.and. Sure, that seems fine. So yeah, a bitwise and should be fine. So we want two conditions here. So I'm going to say I32 and then the two conditions. So the first one is going to be greater than. or rather greater or equal. So it's going to be GE unsigned. Okay. I30, excuse me. I32 GE unsigned. And then this one will be I32 less than or equal unsigned, right? So that should be this one. Less than or equal unsigned, okay? Okay, so now we got to put the two items in here. So the first one will be local get $C, and the second will be a magic number. So decimal for, actually it's 48. Let's see. So this is the offset for char 0. Let me put that note in here again. 48 is the offset for char 0, right? And then it should be 57 for 9, right? 57. So if we look at our Python example and go ord 9, we think it's 57? Okay, cool. Let's hop back in here. So we'll use 57. Let's see. Okay, so we'll do that. All right, so this turned into a super long line. So let's see. So this is the condition. And yeah, it's just a really long condition. So let's put the different parts here. Okay, so less than equal, greater than equal. And then we'll put the then, and then we'll put the else. Okay. So in the then, we put another if else. So let's put that here. So this is going to be if with a condition, a then, and an else, basically, right? Okay, so the condition this time should be length equals 0. So we'll put I32 equals 0, local get length. Okay. Sure. Okay, so in the then, we can see that we are going to set the length to whatever result comes out of our custom int subroutine. So we will say local set, we're setting length, and that is being set to call $custom int. And so when we call, let's reference how we did that here. So we use S functions for these different params, basically, and that's going to be the same here. I didn't do it here because I wrote the custom string a little bit earlier before I was using the S functions much. I do think the S functions, I'm getting used to them. I don't know if they're better or anything. But anyway, so we'll call custom int, and as our parameter, we will put local get $C. Okay, something like that, something like that. All right, so sure, that should be fine. And then we can see that in the else, we did length times equals 10. And length plus equals custom int C. All right. So why did we times equal by 10? That is because if we're going through digits, so if we have like a digit 1 and then another digit 1, so we go get the first digit and we set length to 1. But then if we see another 1 and we have 1 in length already, then we know that that other one actually represented a 10, right? So times 10. I don't know if that, I think that should explain it, basically. So in our else, we're gonna do local set $length. Okay, so then the value will be whatever comes out of I32 mul, right? And it looks like we don't have mul in this file yet. We did use it in the other file. It was part of the formula. But it's just like this, right? I32 mul. This one's simple. We don't have to specify signed or unsigned. So we'll do I32 mul. And in the first multiplicand, is that what they're called? Multiplicand. Let me look that up. Multiplicand. Yeah. So it's a multiplicand and a multiplier. Oh, that's fun. The multiplicand and the multiplier. Okay. Well, I don't know which is which really well. So anyway, so we'll take the first number and it's gonna be the length, so it'll be oh gosh. Wasn't an insert. It'll be local get. We'll get that length. Cool. And then the other number will be 10. So I32 const 10. Easy peasy, I guess. Okay, so that's cool for the else. Okay, I think that covers that bit. And so then inside of this other else, we are going to again have an if. All right, so let's place that. So this will be if. We'll have a condition, a then, and an else. Okay. Okay, looks good to me. Okay, so in our condition, we're going to say I32 equals 0. Local get length. Okay. In our then, so else is going to be no op. And then is going to be local set length I32 const 0. Yeah? Okay, makes sense to me. I'm probably going to leave that one just on one line. Okay, so that's the end of the if. Wait a minute. Should that be the end of the if? Excuse me. No, it should not. So in the else, we're going to do this if first, but then something else is going to happen. We're going to have an inner loop. Right? So let's put this. So here, inner while loop. So this is appending. So I'm going to put loop. The name will be appending. Okay. We'll put the end of the loop there. Okay, and I'm going to put this same note in here because I think it is a good explanation. So here we are appending C to the result length number of times. I don't know if that's actually a good explanation. I think it's good enough for me. So now we have to put the char onto the string. Okay. So let's see. So it's going to be I32 store 8 to put the char there, right? And it takes two params. The first is where are we storing it, and the second is what are we storing. Let me put that note here. Store takes two params. One, where does it go? Two, what goes there? Right, and let's look at how it is here. Nope, it's a memory instruction. Right? So they put store. So first they said the position where to store it, and then they said what to store. Okay, so this first one is going to be I30. Oops, put it in the wrong place. I32 add, and that's going to be local get output length. Let me do offset first. Although, I mean, obviously they are reversible, but I just want to keep it a little consistent. Okay, so output length, so that's where we're going to put it. And then here, okay, let me knock this down and knock this down. So these are what we're adding. And then where are we going to put it? Or, no, we already said where we're going to put it. What are we going to put there? We're going to put local get $C. Okay, so that should be it, right? Okay, cool. So when we do that, one thing we did not have to do in Python is increment the string length, because that is taken care of for us when we did this. So let's increment the string length here. So we'll say local set I32 add, and first is going to be local get output length, and next is going to be I32 const. Okay, cool. Yes, great. So we did that, and then the other thing in the Python is now we have to decrement the length. Call it run length. I'm going to leave it alone, but, well, yeah, actually, I probably should have called this run length. I still need to figure out how to do, like, AST aware, like, refactor replace and thing. Although, regex replace would work for this, too. I still am not super comfortable with that either. Okay, so I'll leave those alone. So we changed it where it needed to be changed, I think, which was in decode. I didn't change it here. Okay, so does that work? Yes. Okay. All right. Okay, so let's actually do it. So local set. Oh, I didn't put what we were setting. So this is output length. Yep, need that. Okay, so here we will set run length. And this will be I32 sub local get run length I32 const 1. Okay, excellent. So that takes care of this part. Okay, so then at the end of the while, we go ahead and we increment the I. So here's our decoding loop. All right, so before we end the loop, we are going to say local set. We're going to set I32 add, local get, okay, and sure. And then, so now we have to decide whether to jump back to the top, right? So we're going to say br if, and first we say, where are we going? So that is going to be back to decoding. And then we say why, right? So that is going to be I32 less than unsigned. And that's going to be local get $I, and it's going to be local get input length. Right? So we'll loop through the whole thing. Amazing. Amazing. All right, so yeah. So I have not done the break if for the inner loop yet. So let's go ahead and add that in. So before we stop here, we need to decide whether to hop back to the top. Right, so if we reference this again, so we know we're going to be decrementing the length. So now we need to say, oh, hey, if, and we're going to go back to appending, and that is it I32 greater than unsigned, and the first is going to be, the first operand is local get run length, and the second will be 0. Yeah. Okay. So that is everything that I had in the Python, I believe, right? Then we return the result. Okay, let's give it a test run. So it didn't compile, but not to despair. We'll fix it quickly, and we'll see how we're doing. All right, so what is it? 184, unexpected token. Oh, the module again. I made that mistake like 5 times now. All right. Okay, so more passed, so getting good. These are kind of ugly errors, though. But some of them did pass, so let's see. Decode empty string, I guess, was okay. Decode string with no single characters. All right, sure. Decode lowercase string. So some of the decodes worked, but we had memory access out of bounds. Darn, that's not good. Okay, so presumably, I guess that means that some loop didn't actually end when it was supposed to. I guess it happens. Actually, I think this is the first time that this specifically has happened to me in WASM. So, it's a learning experience, I suppose. All right. So, let me see. Let me review how the break ifs work. So, we can note that if this is 0, then that will be evaluated as falsy, right? So, sure, let's go ahead and get rid of this. Just do it that way. I don't think that'll fix it, of course. It should be the same. Okay. Memory access out of bounds. So do we see... we see where it's mentioned in the spec, and then we see this. So I think when I go into the editor, it might actually mark that somewhere, somehow. Because I've seen some markings in the editor that I didn't understand, but I don't see one right now, so no luck. Alright. Well, I haven't been at it too long so far, so I think I will finish this tonight. I'm hopeful. Alright. It's a big mess of craziness. Kinda. I mean, I don't know. It's somewhat orderly. Orderly. So, I believe the problem has to be within the appending loop, because when it was single characters only, that worked fine. And the only place we add to the result is in that inner loop. So the inner loop is working sometimes, it would seem. But we are getting some manner of memory access out of bounds. Don't like that. So I'm going to try to print, or to console log, or whatever. Do I still have any of those prints? Let's go all the way up to the top. So the print is supposed to be log mem. I only have it these two places. Okay, well, let's see if I can recall how to do it. So when we are appending, we should be able to call log mem, and let's pass it the string that we are in the middle of building. So that's going to be local get output offset and local get output length, right? I think that's all it has to be. Let's take a look. Oh my goodness gracious. So many X's. That's madness. Okay, let's stop. Okay, well, that's not right. Okay. So in the inner loop, we're trying to decrement the run length, but I wonder if that's not actually working correctly. I wonder if I might actually have these backwards. If I have them backwards, that would 100% explain it. Let me reverse the order. Huh. Did I use sub before somewhere? Yeah, I used it a few places. String reverse. Let's see if it's any different when I reversed that. Well, now I'm looking at A's instead of X's, but no, it's still terrible. Okay, so I'm pretty sure when we do sub, it should be the first minus the second, right? That would be logical, I think. Maybe logical isn't quite the word for it. Where did I go? So we're gonna sub local get run length. Okay, so now instead of logging that, let's log the number. So we're gonna call log I32 unsigned local get run length. So we think it should be a positive number that should be going down towards 0, but clearly that's not what we're seeing, I don't think. Or maybe I misunderstood something else, but I think we're going to fix it pretty soon. Okay, so what's it look like? It looks like it's far too large of a number, so what the heck? Okay, so run length is I32. We set it initially to 0. Okay, so far so good. Okay, so then we checked if it was equal to 0 here. And we set it to call custom int. There are tests for custom int. Doesn't necessarily mean it's working correctly, but I think it is. Here we multiply by 10, but look, I left something out. It looks like I left something out. I multiplied it by 10, but after we did that, we were supposed to add to it, and it looks like I left that out. So we have to add, and the first part is this. And the second part is call custom int. Yeah, so we were supposed to add those together. So that is something that I had left out. I don't think that explains the problem in the inner loop. But that it wouldn't have worked with that not there. So let's look again. So run length. So we set it to 0 there. Wait, that doesn't make any sense. Okay. That's clearly very wrong. What was it in the Python? Uh-oh. Oh, this was 1 here. Okay, so I put a 0 where a 1 was supposed to be, and that actually would explain it. That would totally explain why it was wrong. Okay, let's see if that fixes it. Unexpected else. That's on 210. Let's check it out. They all passed. Well, that's good. I guess I can get rid of the console log or whatever now. Okay, I'm not going to refactor or anything. I am just going to submit it and move on because I still have some time and I want to try and get one more thing done tonight. So let's do submit. Just as it is. And who knows, maybe someday I will come back and refactor it. Maybe before too long, but for now, no, I just want to move on. All right, let's see if it's submits successfully. Processing, passed. Okay, let's see what's next. I'm very curious about this next exercise. So it's called, let's see. Okay, so that's done. So this next one is called Collat's conjecture. I am not sure if I've ever heard of it. It just says 3x plus 1, so I'm not sure what this is. But the programming language, so to speak, is apparently called JQ, which is JSON query. So let's join the JQ track. We're going to go practice mode, local. Let's see what it says. I'm not sure if I expect this to already be installed. I hope so. So let's take a look. Yeah, it is listed in my command completions. And it says I have a 1.6. So let's see if the hello world works. I'm kind of curious. Okay, so let's go to the hello world. I wonder what it is. We're about to find out. So JQ. Okay. So if we run test right now, is it ready to go? Yeah, it is. Okay, awesome. So let's see what the file looks like. This is the simplest JQ filter, just output a constant string. Fair enough. Fair enough. I was very curious, and that satisfies my curiosity. Yeah, so it says good. Let's submit that one. Okay. Well, that was quick and painless. Now let's go to the actual problem. Right, so we'll go back to Collat's conjecture, whatever it is. Crack this open. Okay, let's read about it. It says, it's take any positive integer n, all right? If n is even, divide by 2 to get n over 2. Okay, cool. If n is odd, multiply n by 3 and add 1 to get 3n plus 1. Repeat the process indefinitely. The conjecture states that no matter which number you start with, you will always reach 1 eventually. Given a number n, return the number of steps required to reach 1. I definitely have seen this, probably on Code Wars, but it would have been a while ago. Okay, so you divide. Okay, step 1 gets us down to 6. Lovely. Step 2 gets us down to 3. Then, step 3 puts us all the way up to 10. Step 4 gets us to 5. Step 5 gets us to 16. Wow. Something about this makes me nervous. So it's JQ. We're supposed to do it in JQ. Let's look at the help. All right. So we run it using bats. And we run the bats JQ file. Or do we, what if we just do bats? And then huh. Does this look like it's running actual tests? Let's see. I'm not sure. Oh my gosh, okay. So if we run exorcism test, what is that going to do? So it is running the tests. All right, I'm not going to worry about that. So what is in the JQ file? Def steps implement this function. Okay. Interesting. So if we, I don't suppose there's like a REPL or anything, is there? I don't know exactly what I'm expecting here. So some number is going to be passed in, then we're going to have to do some arithmetic in a loop, and that's it, right? So let's see. Invoking, advanced. Do you think it's advanced? Loop. Okay, so generally things that would be done with loops and iteration in other languages are just done by gluing filters together in JQ. Okay, I need to take a short break. I'm going to flip a coin because I feel like this is something I may want to come back to another day. So if heads, I will try the exercise in a different language first. It's a very simple exercise, but even in JQ, it's probably simple, but I have no idea how to even get started with it in JQ. It'll be interesting when I do it, but I don't know if it's going to be tonight. So let me flip. If heads, I'll do it tonight. If tails, I'll try something else. I don't know where that went. Let me try again. Tails, I'm going to try something else. For now, I'll come back to JQ. I want to get something done, and I have no idea where to get started with JQ. What's the next one? I mean, I know to get started here. It's just going to take me some time. The next one is C#. Okay. I mean, obviously much simpler. I should be able to get this done tonight. We'll see. Man, okay, so the thing that makes me nervous about this is I actually used to work with C# like at my job, but that was a long time ago. And now like I just feel sort of embarrassed whenever I try to work with it because there's just a lot that I don't really remember. But it's pretty simple, right? So we can just literally go our most typical Java-esque stuff, right? We can just go I equals 0, I less than, or no, but we can't do that. So we can go I equals 0. Yeah, let's go I equals 0. And then here we'll go number greater than 1. And then I plus plus. So we'll increment I. But the main thing is that we need to do something to the number. So we'll say if number mod 2 is 0, right? Then number divide equals 2, right? Else number equals 1 plus number times 3, right? So that should literally be it. Now, I'm going to have to put int I equals 0 first, because we need to return that at the end. And just delete it here. Okay, let's try that. Let's see what we get, baby. So it said it skipped 5. So where are the tests? So let's remove these skip properties, right? Okay, so we got a couple failures. So I didn't even read them, but I think they're edge cases that I didn't consider. And in fact, I'm just going to go back into here. So what edge cases need to be considered? So like if the number is less than 1 to start with, then we're not going to know what to do. So let's just see. It says argument out of range if it is negative or 0. Okay. If number less than 1, throw new argument out of range exception. Is that it? Let's see what it says. Let's submit. I am actually fairly satisfied with my choice there because, man, look, see, that was simple enough, baby. It opened up in my other screen. Okay. Here it is. So it says processing. Yeah, that's a very easy. So on JQ, I am not sure, like, it's, if I read this manual, I'll know how to do it. But it's just one of those where I will probably have to read, like, maybe the majority of this manual before I know how to do it. Which I should. Like, I mean, this JQ is a very useful program. I've used it before, but for, like, you know, very simple things, not, like, doing a loop or whatever, you know. All right, so let's hit it. And yeah, it's about the time that I feel like I'm going to stop. So yeah, not a bad day overall, I would say. I think that this WASM run length encoding, I think I would consider this to have been a legit tricky one. I ended up with so much code in here, my goodness. The Python code is still down there. It was definitely harder than it needed to be because it took me way longer than it should have to figure out why this swap wasn't working. And I would like to revisit this to refactor because the code style is not at all consistent here. And this is super hard to read. And honestly, I think that this is quite hard to read also. I think they're hard to read everywhere. So I would like to go back and refactor here, but I'm not going to for now. But yeah, like this one, like, I don't know, very simple, but I don't know how simple it's going to be in JQ. It might not be simple at all in JQ, honestly. Well, actually, let's look. Is it marked as easy in JQ, or what is it marked as? Collat's conjecture. In a C sharp, of course, it's easy. We just saw that. Okay, it's marked as easy in JQ as well, so that gives me some hope. But for now, I'm going to log off and so for tomorrow, I do have work, so I will plan to come back and do some more tomorrow after work. So long, have a good